Hello, thank you for tuning in with us in MedBay. So, this is the second video of the series on coagulation, and in this video we're going to be covering secondary hemostasis.
Secondary hemostasis, the formation of stable fibrin clot. The link to the previous video on primary hemostasis and the formation of platelet plug can be found in the description below, or you can just click here to watch the video now. To understand the formation of stable fibrin clot, there are two main proposed models, cell-based model and classical model. But first, let's have a look at the classical model. Personally, I like this model because I learned a little trick from one of my mates to remember the sequence, and I'd like to share that with you in this video. In the classical model, there is the extrinsic and intrinsic pathway. Extrinsic pathway starts with cells outside the endothelial layer expressing tissue factor, which then combines with factor 7. This complex is known as a tenase as it cleaves factor 10. Factor 10 then goes on to convert prothrombin into thrombin to its active form, which then converts fibrinogen into fibrin to stabilize the clot. With the intrinsic pathway, we start with factor 12. To remember the order of factors in the intrinsic pathway, pay attention to the last letter of these numbers. It's just a trick to remember. So 12 ends with E, so the next factor is 11. 11 ends with N, so the next factor is 9, which ends with E. So the factor that 9 combines with is factor 8. Factor 8 ends with T, so it activates factor 10 and factor 5, which then continues on the common pathway activating prothrombin to thrombin, converting fibrinogen into fibrin. This then results in the stable fibrin clot. So let's have a look at a quick summary. There is the extrinsic pathway, intrinsic pathway, and common pathway. Extrinsic pathway with tissue factor and factor 7. Intrinsic pathway involves factor 12 activating 11, activating 9, which combines with 8. These two pathways then end in the common pathway, which activates factor 10 and 5. This converts prothrombin into thrombin, which then converts fibrinogen into fibrin. Now onto the cell-based model. Cell-based model discusses coagulation in 3 phases: initiation, amplification, and propagation. In initiation, cells outside the endothelium, like the smooth muscle cells, express tissue factor when there is an injury. The tissue factor then goes on to bind to factor 7. As I mentioned previously, the complex of tissue factor and factor 7 is a tenase, but it's a weak tenase, so it activates some factor 10, but also goes on to activate factor 11. Here we could see how the cell-based model shows that coagulation does not involve two isolated pathways like the intrinsic and extrinsic, which don't really interact in the classical model, but actually there is a link between the two pathways. Okay, so the activated factor 10 then goes on to convert prothrombin into thrombin. This small number of thrombin leads onto the amplification phase. Amplification. The small number of thrombin then causes platelets to release ADP. You can watch the primary hemostasis video to learn more about platelets and the role of ADP. The thrombin also activates factor 5. Remember we saw that the tissue factor and factor 7 complex activated factor 11? Yeah, so factor 11 then goes on to activate factor 9. This factor 9 then combines with factor 8. Factor 8 and factor 9 complex is a very strong tenase, so it activates lots of factor 10. Activated factor 10 and factor 5 converts lots more prothrombin into thrombin, up to 300,000 times more than the initial amount in the initiation phase. This is known as the thrombin burst. This leads us on to the propagation phase. The thrombin cleaves fibrinogen into fibrin. Fibrin and factor 13 interweave in the platelet plug, leading to a strong fibrin clot. And that's the cell-based model. If you do have any questions or any suggestions, please do comment below. I'd love to hear from you all.
I hope you found that video useful, and if you did, please leave a like, comment and share this with your friends, and don't forget to subscribe to our channel and hit the bell icon so that you get notified on all our upcoming videos, and we're releasing videos every Sunday. Bye!
I want to reach 1 million likes, so please sarapakara